right. Next one up in our 24-hour live session is Andrei Skupin. He happens to be German also, so we could actually do this all in German. That would be fun, but I think he might prefer to speak in English. I will briefly introduce Andrei, and then it's his turn to wow everybody. So Andrei, we actually met through Sarah Fabricant, which does also amazing work in the science of science and also looking at how people read maps. Andrei is a professor of geography and co-director of the Center for Information Convergence and Strategy at San Diego State University. Beautiful place on our world here. And I guess it's still light there. It's 5 o'clock there. It's 8 o'clock here in Bloomington, Indiana. He's a classical trained cartographer. Actually trained very close to where I got my training in Leipzig, in Germany also. He's building on a wide-ranging expertise in big data analytics and is developing new methods for analyzing human mobility, demographic change, and environmental dynamics. And then in the area of knowledge visualization, his work has combined approaches from text mining, machine learning, and cartography. And it's wonderful that he's really a bridge between cartography and the mapping of science as we know it currently. Andrei is also a co-inventor of several patent pending technologies, and he's the co-founder of a commercial venture. So it's interesting to see more and more commercial products coming out of the science of science. And he's developing knowledge analytics solutions for customers across a range of domains, from data science and analytics to geospatial technology and management consulting. So if you need consulting, there's your man right there. So he has a number of dashboards, which I'm going to put into the chat in the interest of time. Andrei, it's a pleasure to have you here as part of this 24-hour event. And please do take us away.
All right, thank you, Katie. Hi, Kevin, good to see you. So here we are again, just almost 2 decades later. And we don't look a day older, except for me, when I look at my beard. So good morning, good afternoon. Hopefully no one good night, except if you're a European night owl, congratulations, and I'm sorry that you're still up. So what I want to do today is talk about, so the theme of it is the new gold. And this is a theme, a metaphor that's been tried a lot over the years, applied to various things that we in this quote unquote room do. And I have to organize my window here. Give me a second. Okay. And in golden color here, incidentally, the respiratory system. So this is from a map that I'll be showcasing here today. But really what I want to start out with, because that metaphor is so commonly used or attempted, maybe highlight where that is coming from. And there are some surprising connections to the actual methods we use in analytics. And so in one of the early iterations of Places and Spaces, we had the theme of reference systems. And in fact, the periodic table of elements was one of those reference systems. And so when you have all these elements to choose from, why focus on gold? Why say things like data is the new gold or algorithms are the new gold? Well, you're looking for something that is presumably scarce, but not too rare. So it has value, but you must actually be able to get it reasonably. It should be stable. So for example, you might want to put it into a database, and when you get it out of the database, it still says the same, it has the same content. But it shouldn't be so stable to be rigid. It should be malleable, right? So data, you should be able to transform it into other artifacts. And it should be portable, right? So when you, and this is where it connects with cybersecurity, when you put something into a transport stream, you want to get it out the same way it went in. without interference by others or by effectively changing it without you possibly even knowing it. And if you go through the table of elements, so you pretty soon start to exclude noble gases and halogens because they're just too difficult to carry around, as well as mercury and bromine because they're liquid, but also poisonous. Alkaline metals and earths, too reactive as explosive reactions. Thorium and up, well, is radioactive. Rare earths are interesting, except they are too rare. Then we have titanium, zirconium, very high temperature needed to extract from ore, 1,000 degrees Celsius, much too hard to be malleable. And then iron, lead, copper, lots of corrosion. Iron is also not very rare. So what's left are the noble metals, platinum, palladium, and so forth, those 6. And but some of these platinum, palladium, rhodium, and so forth are actually too rare, and some are too hard, like platinum. So what you're left with is silver and gold. And of these two, silver has much more of a chemical reaction, especially with sulfur in the air, and so it tarnishes. So what you're left with is gold as something that has just the right amount of scarcity. It is stable chemically. You can shape it, and it becomes portable. You can carry it from A to B. So that's one reason why data is the new gold, is perhaps a, or calling something the golden solution, the golden goose, the golden boy, why those things are being used. Now, it turns out when it comes to data, that is actually a connection that is much older than one perhaps thinks. So here's a paper from 1951. This was published by a South African mining engineer, Dani Krige, and he basically founded, or much of what he did is the foundation for what we call today geospatial statistics, or in short, geostatistics, which is the foundation for how everyone all around the world performs things like interpolation or filling in gaps, especially when you have data sets where the real world is just too inaccessible and you have to rely on samples. And interestingly, this was about mining, and it was about gold. And it was about statistics and applying statistics profitably towards some meaningful end. And so even as far back as 1951, we were in a data poor environment, and so you needed sampling, and to make sense of sampled data, you need statistics. Now, fast forward to the early 1990s, we've moved into a data-rich environment, and you start to have these mining metaphors coming to the fore, from straight up data mining, database mining, to the notion of the drill down. In all of this, there's the idea that you basically have what you need, but it's hidden in some giant mess, some mountain of data, and you're trying to get to the, and literally the word used was nuggets, which of course is a connotation associated with gold. Now, if you move forward to about 2010, people talked about data being the new gold, and sometimes they said data being the new oil. In both cases, a mining type metaphor is still employed. Well, that has changed. So as of 2020, hydrology, water metaphors have become to dominate the language. We're talking about drowning in data. We're talking about data streams. And so what happened? What is this signifying? And to me, it's signifying, yes, we are data rich, but we are insight poor. And so to illustrate this, I have these two images, right? And if you're a forester, you'll recognize these as images of forest fires. And so you would then perhaps go ahead, and each of these can be geocoded. So let's say the centroid of each image can be in a particular geographic location, and you can go to that location with your GPS, And then perhaps you start to do some modeling based on the wind direction. You start to order evacuation of people and so forth. Well, except that one of these two is just a backyard smoke cannon, isn't a fire at all, and is the wrong spatial scale altogether. So even at this scale, the green texture on the left, yes, they're trees, and some of them are about to be on fire, but on the right, it's just leaves of grass. So the human eye can be deceived. And so what visualization is all about is amplifying human cognition, amplifying skills we already have, but applying them to data sets in an environment where our eyes could perhaps deceive us if we just looked at raw data. And speaking of raw data, sometimes you hear phrases like, whoever controls the data has the power. Well, great. Here are the data. So these are raw crime points in San Diego, city of San Diego, over 6 months, a small section of the city, just a few street blocks. And there's pretty much no pattern in this. The only pattern you see is the street pattern, because the way that crime data are typically distributed in the US is on a block by block level for privacy reasons. And so when you just plot them, there could be, if there's one event in one block versus 10 events in another block, they will just plot on top of each other, so you won't see the difference. So others are saying, whoever controls the algorithms has the power. Well, here I'm using an algorithm, and I would argue as a GIS specialist that it's the right algorithm. It shows the density of crime events. But is there anything, is it operationalized to the point where you can actually act? Is it actionable? And I would say it's not. So then you haven't yet gained the right amount of insight to drive action. So the question then is, well, we have data, we have algorithms, but what is the missing link to create actionable insight? And what I would argue is that it is context. That context is the missing link in order to perform interpretation and inform action. And that's exactly what mapping does. And in fact, if you look at the definition of context, these are 3 different definitions, but they all are highlighting that if you don't have context, you cannot properly understand and assess a situation, and you cannot appropriately interpret what your data are telling you via algorithms. And so I would argue that context is the new gold. And really what I've been engaged in my career is, people talk about tech creators, content creators. I would say many of us in this event are context creators. And in my case, the way I create context is through mapping. And the funny thing is, these are some of the projects I've been engaged in over the last 1.5 decades. And the funny thing is that virtually none of them involved mapping of geographic space or creating geographic maps, even though I am a trained cartographer and I am a geographer and I'm a professor of geography, but none of these are geographic maps. But they all involve space, some kind of space. A network space, a knowledge space, a multivariate space. And then geographic metaphors and cartographic techniques and even GIS technology is being used to make these spaces visible. So for example, the social network of wild pigs, right? Wild pigs create damage in the US alone of more than $1 billion every year. So in order to control the population, you need to understand how they interact, the patterns they form, yes, in geographic space, but more importantly here among each other. And so in all of these cases, some kind of space was extracted and was then analyzed. And that's the common theme behind the work that I'm presenting here. And so if we look at coronavirus, Katie was alluding to that. She was correct to assume that I would be showing something about coronavirus here. what does it mean to see coronavirus in context? Well, it turns out many people have seen coronavirus in context. In fact, arguably, other than tools you use by Google, let's say Google Maps, or tools by Microsoft, or even any web application you can take other than those created by, say, Google and Amazon and a few others, there are few that beat 2 billion views over just 1 year. And this was, at some point, the counter was reset. So this was about almost a year ago. So by now, it's definitely well over 3 billion views altogether. And this is a pretty technical display. But yet people felt it was accessible enough to where they could see coronavirus in context, in a geographic context, and also in a numerical context, like a ranking, to see how countries relate to each other in their sheer numbers, whether it's cases, whether it's deaths, or whether it's vaccinations. And what's interesting about this is you will see this technology again in this presentation, or later when I do a little demo, because I'm using the same technology because it's so proven to get people sort of into the room and stay at the screen and come back to the screen to perform monitoring of a domain of interest and a domain of concern, a phenomenon of concern. So this very same technology, this platform technology, can be quote unquote easily deployed for non-geographic spaces as well. Now, the problem though is that when we're talking about knowledge spaces, so whether the work you saw by Xiaomei Chen or Kevin Boyack, these are very different kinds of spaces, and they're much more complex kinds of spaces. Kevin had this nice juxtaposition of global models and local models. And whether it's a global or a local model, we're doing the work because you cannot possibly understand the domain by just picking up one paper and starting to read that one paper. You cannot keep track, you cannot monitor the domain quite easily. And so this is a pretty small domain, and it grew rapidly. It's also a unique domain in that a year ago, 18 months ago, the domain consisted of perhaps 30,000, at most 30, between 15 and 30,000 publications on coronavirus, and now it has dramatically exploded. So who is supposed to keep track of it? Now, if we zoom out, so to speak, beyond coronavirus, we're all struggling with that. 80 to 90% of today's data are unstructured. It's estimated that workers spend a quarter of their time just looking for the right information to perform their tasks, not performing their tasks, not struggling with their task, but struggling to find the information that will feed into the task. Or maybe going back to Corona, a third of nurses' time is spent on patients, and the remainder, much of it, is about documentation, following protocols. Now, arguably, the documentation, the protocols are about keeping patients safe, but they're also about, for example, keeping hospitals financially viable and legally responsible. And so in terms of finding answers, people outside of our domain, you constantly hear phrases like understand the threat landscape, understand the innovation landscape. But the funny thing is, people who talk about the innovation landscape or the threat landscape, you virtually never actually see a landscape. And so it is just a metaphor, but is it even a metaphor if it's never turned into flesh, into method, and into a real artifact, a tangible artifact? But people talk about painting a holistic picture. How do you do that? Or the need to pare down the decision framework, which to a cartographer means to find the right region and then zoom in on that region and show more on demand. Now, I'll do a little demo later, but here's the link to the result of that effort, of our effort in coronavirus. Now, we did that in March 2020, And so this new literature is not reflected in that. This is basically the state of the literature at the beginning of the pandemic, but it was already between 15 and 30,000 papers. Now, just to see how everything connects, one thing that's typical, Katie was alluding to that, other speakers as well, you typically need a sequence of tools. You need to know, just like any tool-based environment, you need to know what's in your tool chest, and then you need to know which tool to use and in which sequence and with which parameters. Even if you use a hammer, you know, there are different ways of applying force to a hammer. And so in this case, to visualize the coronavirus literature, so SOS stands for Science of Science, so a coronavirus science of science study. We use data from the Web of Science. We used Sci2, so that's coming from Indiana. We've used that for a long time. Then Gephi, then commercial off-the-shelf GIS software, but because it's just so strong in, originally I started using GIS because it's so strong in, once you have a two-dimensional layout, to then make it visually very appealing and very engaging. But it turns out over the last half decade or so, these commercial software products have evolved to become platforms. And so towards the end here, I'm deploying the ArcGIS online platform, specifically ArcGIS story maps. And you've heard a lot about story maps already today. And the idea that spinning narrative, creating narrative out of data, enabling data to speak is so important. And then finally, dashboards as well can be constructed from one and the same spaces. So here you see, this was at the very beginning of the pandemic in the Web of Science. So at the time was about 15,000 papers identified. And going through Sci2, and what I love about Sci2 is these different windows that really help you keep track of where you've been, the steps you've taken, this idea of self-documenting tools, which still today we cannot take for granted. And Sci2 did a really good job. And I strongly encourage its creators, I know you're on this call, to keep updating it, maintaining it, keep up with the Java version evolution, and you'll always have happy users. But then it's important to find the right next tool in that sequence. And so frequently in our domain, in our subdomain, in science mapping, too often we see users sort of stop within one tool and are then limited by what that tool does. And so it's important to push that sequence. If a certain tool is good for something, that doesn't mean it's good for everything. So here I'm stepping on to Gephi, but that's still not enough. I need something that is compatible with GIS platform cyber infrastructures. And in order to do that, I go to ArcGIS Pro for the symbolization, and then create web layers. So then turn the gaze towards the web platform, and then finally integrate it into an online scalable multi-scale map. And so you can see this here. It's actually very easy to do. So that's one thing about these story mapping tools like ArcGIS online. They're actually really easy to use, and it's important that it's not just me being able to do that. It turns out students can easily use these tools as well. So especially GIS students, information science students, it's really easy once you have this other workflow executed to then push that towards the GIS platform and then make it web enabled. So I'll show this to you in a moment. And there's the dashboard as well. Now, as far as the impact is concerned, so it turns out, you know, I don't have 2 billion views, but it's almost 70 countries where we've had active users. And of course, nothing is as satisfying as your your dear colleagues and collaborators like Sarah Fabrikant, for example, at the University of Zurich, giving you positive feedback. Those are, of course, the most satisfying results ultimately. Now, turning a page now, and this is sort of where what Katie was talking about, what Kevin was talking about, the idea, how do you balance what academics do, what academics are interested in, with really creating societal impact? And so my answer has been to thread that balance, that needle between academic work and commercialization through patents. So our company, in fact, was spun out of an NSF project. And so we have a couple of pending patents now, and we're trying to see whether we can take this idea of knowledge mapping, science mapping, and turn them into products that operate, that allow people to work on them in the same manner in which we use Google Maps, traffic mapping, climate mapping, performing overlays, performing monitoring. If you're thinking about an emergency operations center, an EOC, there's no EOC in the world that doesn't have a giant map display. And that giant map display is not a simple line graph. It is a complex underlying base map into which then pertinent information is overlaid. Can we do that in these more abstract science domains? And can that help us to improve inefficiencies in our knowledge ecosystems? Because we all are actors that produce and consume artifacts in our various domains. And our approach has been to say, well, can we create a space inspired by geography, by cartography, by GIS, by GPS even, that is integrated, meaning there's a reference system and you can project into the reference system. It is operational, right? So it's not just a pretty picture. You can do things with it. You can perform tasks with it, and it's evolving over time. And so here's a schematic illustration for example, a skills domain. And we've heard something about skills development today as well in various contexts. It was at least sort of a halo. So if you have a knowledge space, right, what an organization does, the skills it needs, the skills it deploys, could be represented. And in that same space, a job, maybe a job description, a job that is actually to be performed, should be projected, and then a person. And the interesting things happen at these intersections of these sets. So, for example, the ideal intersection is number one, where a person's talents match a job within the organization scope. Now, you have to be careful. If that's the case, you want to keep that person. You want to select the right person to create that intersection. If you have that person, you better try as hard as you can to keep them. But for example, intersection number two, where the personal talents are outside of the job scope, but relevant to the organization. So there, you need to be careful to make sure that perhaps if you learn this, if you have a tool to make you aware that a person has talents that are actually relevant to you, but are not being used in their current job, that you are redistribute talent accordingly for greater job satisfaction. And in other cases, personal talent like number three, where some person's talents don't yet extend into what a job requires within the organization, well, then perform talent development, training, shadowing, and so forth. Now, let's make this actually happen. So what does it take to make that happen? What are the characteristics of making that happen in our approach? So we are inspired by geography, cartography, GIS, and GPS. So first is a detailed high-dimensional reference system of a domain. Domain could be chemistry, management consulting, data science, anthropology, and so forth. And this reference system is separate from the map. Just like the latitude-longitude system, this curved two-dimensional system that spans the globe is independent of any particular map. And so then you need a base map, a detailed inventory of the land, so to speak. And it's not a new idea that this should be done at multiple scales. So when people talk about overview first, detail on demand, cartographers look at that and say, well, yeah, we taught that in 1901. There was this textbook, Allgemeine Kartenkunde. That's about the only German word I'll say today. And it shows that scale change is more than just sort of dropping details. It's not like level of detail control in gaming. It's much more about semantics, semantic shifts, changing from seeing something, for example, as a point to seeing it as a polygon, or switching between notions of something as a discrete entity versus a continuous field occupying space. So can we make that happen for knowledge spaces? Then you need an inference engine, right? So it shouldn't just be a pretty picture. You should be able to basically have a GPS for knowledge. You should be able to project an artifact into this space, an artifact that may or may not have been part of training this model. So for example, social media artifacts projected into a space created from news articles and vice versa. And then finally, there has to be a knowledge analytics framework so that you can perform tasks, be it recommender engines, gap detection, and importantly, gap filling. So that's something in talking with potential clients, we see over and over the need to find gaps and then fill gaps. Tell me what it is that we don't do that we should be doing, and how do we get to actually be doing that? There's a lot that came before that, and some of these were projects, in fact, with Katie and with Kevin. So in the bottom left, for example, here is this analysis where we made a base map of the biomedical domain, but it wasn't really multi-scale yet. But what we did do is it was such a large space, it was so high dimensional, this biomedical space, that we had to use supercomputing and parallelization. And that's where this collaboration with Katie's team was just super productive, and with Kevin on that project. And then we had a little fun and applied the very same technology to 1 million music items. And you see a little snippet there in the top. And on the bottom right, that's a map that's actually in the exhibit as of 2005. Now, what none of these had was real multi-scale interaction, multi-scale representation. And so that's what this platform, BOKMap, Body of Knowledge Map, is trying to do, where we have a base map, but it's not just a single pretty picture, it's in fact multi-scale. And so you can see there's more and more detail being revealed. And what's important is that underneath this reference system is incredibly detailed and deep. So something we discovered after the fact, we created these two base maps and underlying reference systems were created before 2020. So before the COVID pandemic. And yet, we found out if you type coronavirus in them, it actually finds that concept, but it finds them in domain-specific contexts. So in data science and analytics, it finds them in health, near medical diagnosis, clinical trials, near public health. But in geospatial technology, it finds it underneath spatial analysis. That is the broader context there. And then ultimately in health. So health here is within spatial analysis. So coronavirus, first of all, it's there pre-2020, but it appears in different contexts. So context can be, and frequently and typically is, domain specific. And then finally, what can you do with this? So this is the range of things that you can do. First of all, learning, just interacting with the map. And something we discovered I wouldn't say accidentally, but we were slowly navigating towards that, is the fact that you can learn the domain while interacting with the map, and then with a simple double click in the map, you can query a database. You can query a database of documents. So you don't need to know the language of the domain. You simultaneously, serendipitously discover and can query the domain literature. Finding overlaps between people, between organizations, between activities, finding outliers, the things you didn't know about, the unknown unknowns. And so here's an example where we have speakers from a conference overlaid, and you can readily see how the red and blue speakers have more in common, and the green speaker is more focused on the technology aspect here within the management consulting space. So think about team management, team composition, ensuring synergy, that there's not too much duplication, but significant enough overlap to ensure communication. Right, finding gaps. Here, someone's CV overlaid onto the data science space, and there's a donut hole, literally a donut hole. So now, in other words, the system is saying, the model is saying, listen, you're really good. It seems you're at home in this part of the space, but there's a hole here. Why aren't you doing that? Now, it could be that it's for a reason. Like, for example, in intelligence work, perhaps an entity doesn't want you to know, so they hide certain sets of artifacts, but those gaps nevertheless then appear. By their absence, they make their presence known. In this case, a CV, you could then ask, okay, if you want to work in this area, you're well qualified, but let's see what would fill these gaps. Oh, electric meters, smart grid, smart meter systems, electrical substations. Learn about these concepts. Now, one thing that's important is that it is a platform, that it can be integrated, ingested by other software, by other services, by other platforms. And so an example here, this is the by far most well-used, most well-known open source GIS software, desktop software, QGIS. And QGIS, it accesses, it uses a lot of standard-based technologies, and so do we. So even though this is a GIS and it expects geographic coordinates and all of that, we're actually making it possible by the use of standards to ingest our non-geographic spaces, both the base map. These are simple tile-based maps, just like when you use Google Maps. And then we have overlays, so every query becomes an overlay. Here are the personal, again, speakers from a conference overlaid. And monitoring. Here, for example, thousands of job ads overlaid on the data science and analytics space. And sometimes you operate completely within the reference system. So on the right, for example, here we're plotting. This is not simply looking for the term artificial intelligence. It's looking for the concept artificial intelligence and everything that it, in a latent sense, entails. And you can see that in this data set, we found that it peaked in 2017, as did deep learning, while grid computing is actually a quite stable concept. Now, we've done this in a couple of domains. We've deployed this system, data science analytics, management consulting, and now geospatial technology. And just to illustrate, so we did this here with the Open Geospatial Consortium, which is the largest industry standard setting organization in the geospatial technology domain. You can see some of its members here. And we've had really an incredible footprint where people are interested in learning about geospatial technology. And this is just the base map. This isn't yet even a deployment where we're linking databases of documents with it. But I'll show you a demo of that in a moment. So obviously, feel free to jump in with questions. I'm going to switch now to actually show the show you some of these examples, and feel free to, again, jump in with questions. So here is the coronavirus story map. Again, this is out of the box commercial GIS platform technology, but we're feeding the result of this Web of Science, Sci2, Gephi, ArcGIS Pro workflow into it. And you can now guide people, and it is important with these maps. Even though we're using GIS technology and we're using common metaphors, they are different enough, these artifacts, that they need guidance. And that's where story maps can really do a wonderful job of getting people into it. And what I have students do in my knowledge analytics seminar, they create this for, say, their master's thesis or for their honors thesis. They illustrate what they're working on, and they become engaged, but they become themselves science communicators by creating things like these. And then alternatively, so as I said, this is the very same technology that the Johns Hopkins University dashboard uses. You can see the widgets. There's a certain similarity because it is one and the same underlying technology, except it's this this knowledge space that you're exploring here. They're actually ranked by centrality. So we're actually using network measures in this particular case. And the panel down here, those are actually live Wikipedia lookups. But different technologies, it's so important to always use standards whenever you can. And so here, for example, this lookup from concepts in COVID to papers, to scientific papers, is actually driven by our BOCMAP platform, but not the BOCMAP mapping aspect, but the reference system. So here the match from MERS-CoV to the scientific literature is based on our BOCMAP reference system. So it's important that you have this modularity and you can mix and match different services. Now, finally, here is the data science and analytics base map. And you can see as you zoom in, finer details emerge. And yes, you can perform overlays. So for example, if I search for coronavirus here, it is a probabilistic query. So every once in a while, it will pop up somewhere else. That is not a bug by the feature. Just like in the real world, a given concept can have different connotations, appear in different contexts. The majority of the time, about 90% of the time, it will appear in the health domain. Every once in a while, it will pop up in a data structure domain, which is about how data about coronavirus are being distributed. Well, what's important is we can actually loosen our restrictions. So it turns out we don't actually map these concepts as points. Instead, we're revealing the peak of the probability distribution for coronavirus. That becomes the point, and then we're relaxing it. And you start to see secondary areas of relevance and relatedness. Now, this can be done for other domains. So here is the management consulting and accounting space, for example. And here embedded at the OGC website is the Geospatial Technology Explorer map. Now, what we're most excited about now is to link this with document repositories, and specifically the ability of performing queries not simply by text, right? So here, for example, we're searching for GPS and it found various mobile technologies. But rather, we can also search in the map itself. So to illustrate that, to use, for example, and also maybe show you maybe an outlier discovery. So if you search for blockchain, so 93% of the papers are mapping at this border area between business. So there's business and there's society. So blockchain is a key concept at the intersection of business and society, and not too far from financial crime. But there's an outlier. So these are all here in that main area. How can we get blockchains to talk to each other? In fact, that's a very recent paper. But there are some outliers here. So if we look at this, this is in the national security area. There's an outlier. Iran inches closer to unveiling state-backed cryptocurrency. Now, I didn't look for national security specific papers, but or publications or news items in this case. I discovered that, right? So there's the main body of literature dealing with blockchain, but then there are outliers. So we're discovering these unknown unknowns, these things that we didn't really look for. But what I'm most excited about is the fact that, let's say you don't really know much about data science and analytics. You can still query the space. So for example, if I go into biological sequences, and I can just double click here and it will perform a query for items that relate to that location. And notice, by the way, how this is where I click, this is where these items are located. So I'm not asking where items sit in the map. I'm querying based on where I query on the map. I'm going to the high dimensional reference system. I get the items that are most similar and then see where they fit on the map. And so the reason why they don't sit right on the location where I clicked is because similarity ranking of items against each other is not symmetric, right? I can be your best friend, that doesn't mean you are my best friend. And so, but the best friends of this location that I clicked here are these papers here. Now, you can actually perform Boolean intersections. So I can just add another query location into this. So for example, this was biological sequences, DNA and so forth. And let's say we intersect that with privacy concerns. So I can just add another location, and of these tens of thousands of papers, it quickly drilled it down to just the top 4 that match. And you can see in green, the top ranking one, yeah, it is genetics and privacy intersected. And then if you want to find more like this, well, then your typical more like this button is there as well. And yes, you can do that for other domains. Now, where the circle closes is, how do you, this is, of course, it is engaging, it's highly visual. People comment on the fact that they've never seen anything like that. But at the same time, it's complex enough that it requires serious explanation. And that's where the circle closes, that we actually use story mapping technology to explain ourselves, right? So this is actually an ArcGIS story map that we're using as our help system here, as our information system, telling users, informing users about how the platform works. And you can see here, we have a pretty good footprint across the globe there as well. And there are some pretty neat new types of analytical capabilities. Yes, of course, you can query by text or query by example, more like this. You saw simple map queries, intersections, but you can also do more complex. You can actually draw on the map different geometric figures, circles, rectangles, even transects, and have that be the basis for a query. So you could think of this as the first steps towards a kind of geofencing of knowledge spaces, where you could monitor a particular region of the knowledge space and it would keep track of that vis-a-vis some document stream. So I think I'm going to stop there and see if there's if there are some questions.
Great presentation. So Kevin, before he had to leave back and go back to his kids and grandchildren, he's pointed out that you are the best map maker out there. And thanks so much for showing us what can be done with these maps of science. So my question for you, what would you do if you would have even more resources? What are the key science and technological challenges that should be overcome as soon as possible to scale up all of it?
Right. So broadly, maybe to start with, what's hard and what's easy. So what's relatively easy is performing overlays. Right. So, for example, when I type a query, the response is instantaneous. So projecting into these spaces things that weren't part of these spaces, documents, whole abstracts, for example, is super fast and super easy. On the other extreme, it's creating the base map is super intense. It doesn't actually take that many documents. So we typically use around 100,000 artifacts. And then we perform computations to find latent domain structures. And then we perform dimensionality reduction with self-organizing maps. But there is an element of curation in that. And so none of the graphic structures, geometric structures you see in the map, none of them are created by hand. None of them are curated. The only thing that's curated are some of the labels, not the placement, but what the label is. And so that when you have, I can tell you that this is I think, 1500 dimensional space. Or it's 1,000+ dimensions, and each of these dimensions has a label, and somebody has to come up with that label. And sometimes it's done automatically, but I'm not satisfied with that. So we are curating some of those labels to make them the maps more legible, understandable, where people say, "Oh, I know that concept. This actually means something to me." Also, in order to ensure this scale dependence, right? A top-level domain should have a more generic, a top-level layer or concept should have more of a generic name than a fine concept, a bottom-level concept. Now, the bottom-level ones, most of what you see are actually automatically generated, but the top ones, like people that publish on data science and analytics in some business context, may not ever use the term business, for example. But somebody then has to curate, wait, at the very top level, we're talking about business here, as opposed to academia or software development. So that is a bottleneck. It's computationally pretty intense, but it's manageable. But generally, the base maps can evolve, but evolving a base map is much more difficult. And I always make the separation between the evolving base map and reference system versus monitoring evolution on the base map in the reference system. And that's always this careful balance. When you say movement, anyone who says movement, basic or change is movement in some space. And in order to identify it as change, you must have something kept stable so that change can be observed. And so on purpose, that's one reason why we actually keep the base maps and reference systems relatively stable over time, for longer periods of time, then the overlays, which can be very dynamic. People, activities can be traced, the evolution tracked on top of these maps.
I think there are many systems out there which give you a different base map every single time you run UMAP or TSNE or any other dimensionality reduction technique, and then you are in front of a new base map. You have to learn it, and it takes quite a bit of cognitive effort to learn that base map. You might remember how much time it took you to learn the map of the world. You had to learn that this cat up there is like the Scandinavian countries, or the boot down there is Italy. So I think people are trying to get metaverse to help them remember a certain area so that they can draw this outline one more time. And I think people, if asked to draw an outline of the world map, most of them would have a hard time. They might be able to draw the outline of their own and neighboring countries, but it gets maybe less and less accurate as you go outward. It's actually a quite nice exercise if you start a kind of data visualization class to just ask them, yeah, can you give me that reference? And they can do this for a table, they can do it for scatter plots, they can maybe also do it for some network layout of their family members, but it gets harder and harder the larger these references get.
And by the way, these base maps, their lifespan can actually be surprisingly extended because of the detailed reference system. So for example, if there's a concept where you type it and it comes back saying, we find, no, this is not here. Like, I don't know, some new technology concept where the term literally didn't exist when the base map was created. But the funny thing is you can still map the concept by just taking a description of the concept, like an abstract that describes this new technology. It will definitely be able to map it then. There will be existing concepts, because as you know, nothing is ever invented from scratch. We all stand on the shoulders of giants. So when there's a new concept, you just have to find the giants and map them into this, the giant concepts in this case.
Yes, great ending of it all. Andrea, thank you so very much for this great presentation.
Thank you. This was fun. Last thing I said before the power went out, thank you for what's behind my shoulder.
I see it. All right, it arrived. Wonderful, wonderful, wonderful.